What's going on, people? Let's talk about levers. All right, so let's talk about a first class or a class 1 lever. That's just the way they identify it with. All right, so it's very basic. You see it a lot. You see the fulcrum in the middle. All right, you could input a force down and you will output a force up. That's how a class 1 lever works. But let's look at it another way. What about this? If you input a force up on this side, what do you expect to see on this side? Well, you expect to see an input of a force down. So this is how a class 1 lever works. And it essentially works the same as a pulley. You're right. The object of a class 1 lever, or the objective, is to redirect the force, but you have to do the same amount of work for the same, you have to apply the same amount of force over the same distance. So class 1 lever is directly in the middle. All right. Or I wouldn't ever say, a class 1 lever isn't always necessarily directly in the middle, but it is in a situation where the output is on the left side of the input, or and vice versa. The output is on the opposite side of the fulcrum as the input. So when we look at a pulley, right, we have some block mass here. If we input a force down, we get an output of a force up. All right, now let's look at another example. Let's put the fulcrum on the very end, all right? And let's input a force. Sorry, I didn't have that in focus. All right, so here's our fulcrum at the very end. We're gonna input a force on the very end right here. We output a much larger force, actually, all right? And this gives us a mechanical advantage of 2. Now let's look at a pulley that can also give us a mechanical advantage of 2. Let's say we have a pulley like this. It's attached to a mass, but instead of it being attached to another pulley, we're gonna do this. Say, okay, there's a ceiling right here. The rope is attached to that hook then, and we're pulling on the rope this way. So now we have an input of a force this way. The rope is also inputting a force this way, same as us, so we get an output of double the force. This right here is called a second class lever. So if you input, you can input a small amount of force a large distance away from the fulcrum, and in between the fulcrum, you get a large output of force in that same direction because the distance from the fulcrum is smaller. And we see this relationship as what? That's right, as work. Our work equals our force times our distance. So the work remains the same. We want to do 15 joules of work, and we're 75 centimeters away. What's the force we're applying? Well, we're applying 15 divided by 0.75. And we say we are applying a force that's equal to 20 newtons. Well, what about if, okay, we're applying a force, what's the output of force? We have the output of force is actually only 30, we'll call it 35 centimeters away. So we know it's going to be 15 joules of work. It never changes, right? But what's our output of force? Well, say F is equal to 0.35 divide, and let's do 15 divided by 0.35. And we'll say that's equal to 42.86 newtons. So as you can see, it's about doubled as you go in about half. So this is really how your mechanical advantage works, and you can think about it the same as a pulley. Now, I know we're not really used to seeing pulleys like this. We're used to seeing double pulleys. And really, the way it works is the direction that you pull the rope is the direction that the rope is inputting a force. So I'm going to give you a couple of questions. Go ahead and complete them.